I'm Therese, and today we're going to build Project 4 from the project book, the color mixing lamp. This project uses 3 light sensors to read the light, each covered with different colored gels to only let through certain wavelengths. The amount of light that each sensor absorbs will determine the color of an RGB LED, which is the output. Open your book to page 53 and take a look at the components we're going to use for this project.
The light sensors we're using are called phototransistors, which are more or less backward LEDs, but instead of emitting light, they absorb it and generate current, depending on the amount of light they absorb. In the previous project, we used the temperature sensor with analog pins to read analog signals. This is because analog signals can have multiple values, not simply on and off, like digital signals. In the same way, phototransistors can sense various values when absorbing the light. Be sure to check out Project 3 if you haven't. With the Arduino Uno board, we can use some of the digital pins for something called PWM, pulse width modulation. The pins that have the tilde next to the pin number, for example, digital pin 3, can use PWM. Read more about PWM on page 53. Today we're going to use it together with the RGB LED. An RGB LED is a diode with separate red, green and blue elements inside, which makes it able to light in all 3 colors and also mix them, creating a wide spectrum of colors. It has 4 legs, 1 for each color and a 4th for ground. On page 55 in the project's book, you can find a more detailed description of the component. To decide how much to mix and fade the colors of the LED, we're going to use different colored gels on top of the phototransistors.
For example, the phototransistor that has the blue gel on will only detect blue light. We'll then use this information later in our sketch to determine how much blue light will come out of the RGB LED.
Let's see how it works. But first, make sure that your board is not connected to the computer. I'm going to start with preparing the phototransistors, so that each one of them has a colored gel covering them. I'm using these orange pieces from the base plate as a plate for the phototransistor. And then taking a gel, covering the phototransistor like this. I've connected the power and ground already, but for this project I also want to use this power rail. So I'm taking a jumper wire and then connecting one power rail to the other side. Oops. Like this. So now we have power both here and on this side and ground only here. Now I'm gonna do the phototransistors. As you see, they have one short and one long leg, just as the LEDs, where the long leg goes to power and the short leg goes to ground. I'm starting with the green one, and I'm gonna place the long leg on the side of the power and the short leg on the other side. So I want this leg to go to this power rail. Now it's connected to power. And before connecting the short leg to ground, I need a resistor for this. So I'm going to take the 10K resistor and place it in between the short leg and ground. Finally, I'm taking a wire to connect the phototransistor to analog pin so that we can read what value it's reading. So from analog pin, this is green, so I'm using analog pin 1. And somewhere here, in between the resistor and the phototransistor. So now this pin will read information from here. Now I have wired all of the phototransistors. If you find it difficult to keep the gels in place, you can use a small piece of tape. Now I'm going to connect the LED. If you place it on the table, you can identify that the longest leg is the ground leg. To the left, you have the red, and the 2 other ones are blue and green. I'm going to connect it with the red one on top. I'm connecting ground pin to ground. There. Then I'm connecting all of the colors to pin 9, 10, and 11. So I'm going to use the resistors to connect the pins to the LED legs. Here I have connected the legs of the LED through 220 ohm resistors to the pins. Let's connect the board to the computer and upload the sketch. Now we can see that the LED is using all of the colors. But if we cover these two, for example, we can see that it becomes more red. When we have a variable that is going to keep the same value throughout the sketch, we can use a constant. This is useful, for example, for storing pin numbers. Like we learned in the last project, with analog read, we can read values between 0 and 1023. With PWM, we can send values between 0 and 255. That is why we need to divide the 1023 with 4. For example, when the phototransistor receives a lot of light, we read the highest value, 1023. Then, if we would divide it with 4, we get 255.6, which will make the LED as bright as it can. We need to send 3 values to the RGB LED, 1 value for each color. If some of the LEDs doesn't seem to work, you can use the serial monitor as your help to check if you're sending the right values back to the board. If you can see that all of the values are 255 here and the LED is still off, it might be that the component is not connected properly.
Now that your project is working, the next thing you can do is to modify the code. How would you use your phototransistor? If you have a project, share the video with us in the comment section. Next time, we will start using motors. See you!